Hey everyone. So today I'm going to walk through how to use the Tuva project to generate expected values from our risk-adjusted benchmarking MART end to end from start to finish. So to start off, I am working in the CMS synthetic connector, which of course has the Tuva project as a package that is brought in. And within the latest version of the Tuva project, there's a folder called benchmarks, which is the new benchmarking MART. And that's broken up into two subfolders, a pre-predict and post-predict. The purpose of the pre-predict models are to prepare the data to be used by the prediction code itself. And so there's two final tables in this folder. One of them is at the person year grain, and this is used to bring in all of the features that are going to be used by the model with one row for every person per year in our data set. Then the other final table that's used is the inpatient input table, and this is at the acute inpatient encounter grain, but again has one row for each of the features that are potentially used by the machine learning models. So in order to run this portion of the benchmarking MART, we need to enable a variable. And we can do this either via the command line or in our dbt project.yaml. Let's just do it in the command line here. The variable that we want to set to true is called benchmarks train. And in order to run just this subset of models, we're using the tag benchmarks train as well. So let's go ahead and run that. Now that that's finished running, we can go ahead and take a look at those tables in Snowflake. I've queried the tables here, benchmarks.personYear, and you can see that we've generated at the person year grain these wide tables. And so one row per person per year with columns for each of the features that is potentially used in the model. The next step, now that we've verified this table ran correctly, is to run the benchmarking models themselves. And so you can get them from the Tuva project's organization page on Hugging Face. If we scroll down to the very bottom here, you can see we've got two different model pages, one for each of the different grains that we're predicting at. So if we switch over to the page for the Medicare costing counter model, this is that person year grain that we were looking at. If we click on the three dots, this will give us the command to just clone the repo and download the model itself locally. So I can do that here. I've actually already cloned it and brought it into my workspace. You can see the repo contains the model bundle, which is a pickle file that has everything we need to run the code, as well as various other files that we can use. The prediction notebook that we'll be jumping to in a little bit, as well as evaluation statistics, feature importance, and other useful CSVs. Okay, let's jump over to Snowflake to actually run the prediction code itself. So this notebook script, which is in the repo, should be pretty much plug and play for the Snowflake environment. The couple things you might need to change are in this configuration section here at the top. This is our input as well as output database, the input of the person year table that we ran earlier, and then where we want to output the table to, the schema that we're using. And in addition, we want to add the bundle containing all of the model information and weights to our Snowflake staging environment. And then we also want to add this feature fill rate CSV that we'll do some comparison on in the code as well. So once these are all pointed to the right location, we can just click run. And this should run pretty quickly here on this. Okay, we can look at our encounter predictions table here where everything ran. This table is still at the person year grain, but now we have added columns for each of the predicted paid amounts and encounter counts. So we have one column that's the overall paid amount, and then we have columns for each of the encounter groups: outpatient, office-based, inpatient, and other. And then we have columns for each of the encounter types. There's 30 odd encounter types or so. In addition to the paid amounts that we're predicting, we're also predicting encounter counts for each of those. And so you'll see those columns with the suffix count. It looks like everything here is good to go. The last step in our process is to then bring those prediction tables back into the Tuva project for some calculation of observed to expected, as well as data visualization and other analysis that we can do. So in order to do that, we need to run the other portion of the benchmarking MART, this subfolder called post predict. And to do that, we need to make two changes. We need to add sources that point to the output predictions tables. And so I've gone ahead and added a sources.yaml that point to the database, the schema, and the table names from our prediction code. The other change we need to make is in our dbtproject.yaml, we need to add variables that point to those sources. This is because the Tuva project references those variables in the post-predict MART, and so we just need to define those variables that point to those sources themselves. Once we've defined those two things, then we're ready to actually run this portion of the MART. So we can do that by setting another variable to true. This one is benchmarks already created, and we can run just this subsection of models by using the tag benchmarks analysis. So let's go ahead and do that. Okay, once that's finished running, we can then jump over to this Power BI dashboard that we're also making available to do some of those observed to expected analyses and comparisons and data visualizations. So we've got two tabs in this Power BI file. The first is looking at the PMPM and encounters. You can see that we have a dotted line where all of our expected values are coming in, and we can compare that to our actual values for each month in our data set. We also have predicted hit amounts and encounter counts by encounter group. And so you can see those expected values coming in for each of the encounter groups. And then below, I've only brought in the top 5 or so encounter types, but you can see some of the most common ones like inpatient skilled nursing, home health, ED, where we are predicting an expected encounter count that we can use to calculate a PKPY. And because these expected values are brought in at the person year grain, we can slice and dice these expected values by any subgroup or cohort in our data set. And so I brought in and compared this to the chronic condition MART. And so we can then see the expected values change for each of the cohorts in our data set. For example, the type 2 diabetes group has an expected value that changes compared to hypertension or some of the other chronic condition groups. The other tab in this Power BI file shows the expected values for length of stay in comparison to actual. It shows our expected readmission rate over time compared to actual. And then you can see the expected discharge location for each acute inpatient encounter. And because these are brought in at the encounter grain, we can then use some of the encounter fields and join to that table, such as DRG, facility ID, or facility name, to slice and dice and see how the expected values change by each of these dimensions within our data. And that's it. That's how you generate expected values and risk-adjusted benchmarks using the Tuva project.